All right, quick refresher on how to pull data from a simulation, throw it into a table in Desmos, and look at a relationship. So we're going to do, let's say, resistance and current here. So how do I change the resistance, and how does that affect the current? So I'm going to set up a table. I'm going to pull X and Y data, and my independent variable thing I'm going to change is resistance. So we'll make that R. And you can tell I'm outside the bathroom right now. And the current is a capital I. Impetus, because Latin, it's weird. We'll go with it. Okay, so pulling resistance, we can change. I'm going to go by tens here. Actually, let's take it back. Let's go by ones. 1, 2, 3, 4, 5, 6, 7, 8, 9. Great. So as I have, all right, I've got a 10 right now, and that's a current of 0.9. That's how it started. So I'm going to throw it into 0.9. So if I turn the resistance down to 9, current is now a 1. And if I turn the resistance down to 8, current is now 1.12, and so on and so forth until I get the rest of the data. So I'm going to like a cooking show, pause for a moment. Okay, so we took some more data, and I have a couple of here, let's see, 3 ohms. Let's finish it up together. Gets me 3 amps. I see it being graphed over here to the side already, and I already can kind of tell it's probably not linear, even though they are going in opposite directions. Let's see, 4.5. And if I already go down all the way to 1 ohm, wow, jumps all the way up to 9. So looking at the data here, when it's not obvious, I can look at, this is the power of doing this in graphing it and looking at it, is I can see this relationship is probably an inverse relationship. It's not linear. So if I want to add this, okay, that would mean that current here, which is on the y-axis, equals 1 divided by x. Let's look at that. Okay, so it's close to that, but it's not quite. And I'm going to adjust the values here to adjust what I'm looking at. Yeah, all right, there we go. So 9 kind of brings it into line with all of those. And I'm just throwing in numbers to kind of adjust to see, okay, what brings it in so I can tell if it's close to those numbers or not. Great, so I can tell that resistance, current, they are inversely proportional, y equals 1 over x, or current equals 1 over the resistance. And if I dial in that number up top, which, spoiler warning, is the voltage, that shows me this relationship between those two variables. So remember, we have a simulation, one with the independent and dependent variable. You added a table in Desmos, pulled in some data, some X and Y data. I relabeled it so I know what I'm looking at. And we can look at the relationship here. If the scale starts getting wonky, you can change that with the little settings on the side here to zoom in or spread something out to see something at a different scale. So that's the idea. Data from Desmos. Hooray.